Hello friends, this is Computer Networks lecture number 3. Previously, I explained all GFX generator polynomial function, message polynomial function and transmitter transmitting protocols. Transmitter transmitting protocol function, which is transmitter polynomial, and reminder polynomial function. I explained this example in previous lecture. Now I will also explain here. In short, this is GFX generator polynomial function, which we will use as a divisor. This is a polynomial function which binary string is. This is the binary string of this generator polynomial function. At a place of 3, degree of 3, there is 1. Therefore, degree x of x to the power 2, and there is x to the power 1, which is not in here. That's why it's 0. And x to the power 0, it's 1. Same as message polynomial function. Message polynomial function, whose binary string is this. Now, the transmitter protocol polynomial function. This is a message. After multiplying x with the generator polynomial function degree, the resulted polynomial is this, and the resulted binary string is here. After doing the modulo 2 division with transmitter protocol with generative modulo 2 division with generative function, here the protocol and there is a g of x string. After dividing, we get the remainder, which is 0, whose polynomial string is this. This is a binary string of remainder polynomial function. Here is the remainder, we get remainder this, and this from this binary string we get the polynomial function, remainder polynomial function. This is also known as CRC. This is called CRC. Okay, the remainder polynomial function is this. Here in transmitter, what the transmitter will transmit? In transmitter will transmit, there is a transmitter protocol. This is a protocol in which they add a reminder. There is a transmitter protocol polynomial function. This is a reminder polynomial function. After adding both, the resultant polynomial will be sent through the network to the receiver. After adding these strings, these binary strings, here the protocol binary string and there the CRC binary string, we get the resultant is this. This is a resultant of message protocol polynomial function plus reminder position. Here plus I have added transmitter protocol. In transmitter protocol function, we have added reminder polynomial function, and the resultant binary string we get this. Now the receiver protocol means what happened when the receiver receive the transmitted polynomial function or binary string, is the when how receiver will process the accepting string or string transmitted by transmitter. This is a string transmitted by transmitter. Here the receiver will receive what? M of x with x of n. N is the degree of generative polynomial function, and RF is a CRC beta. CRC polynomial, remainder polynomial. After dividing this with generative polynomial function, we already know that m of x and x of n is not completely divisible with. If divisible, then remainder will 0. If not divisible, then there should be a remainder. After adding remainder, after adding remainder in transmitter protocol function, if we divide again it g of x, then absolutely remainder will be 0. So Here, same method will be applied. There is a reminder at receiver side. If the receiver received string will be divided by generative polynomial function, then there are two conditions. If the reminder at receiver side will be 0, then there is no error. There is no error. So the receiver concludes there is no error and accept the incoming string. But if the reminder will not be 0, then what happened? If the reminder will not 0, the receiver detect error and reject the string. Error detected means if reminder is not 0, then the receiver will detect error and send acknowledgement to the sender or transmitter to send that string again, that frame again. Now here if the user or receiver receive the corrupted string, means that if the receiver received corrupted string, then this happened because of error in the string due to the noisy channel, or means adding or changing the bits, means adding extra polynomial function, which is also which we called error polynomial function, where x is the power of I, where I is equal to 0. Here we conclude if I to the power 0, then it should be a error of single bit, means that if the power of x to the power I means I is equal to 0, then there should be a one terms in error polynomial function. If there is a one term in error polynomial function, then it should be error of 1 bit. If there is a n bit in error polynomial function, then it should be a error of n bits. Error polynomial function will change the transmitting polynomial string. Here, if there is no error polynomial function, if there is no error polynomial function, means error polynomial function is 0, then there is no error. But if there is only one terms, which is x to power 0, x to power 1, anything, it should be a error polynomial function. If we have, it contains single terms. Okay. Now, how we'll conclude what the reminder will receiver get? If this is a error polynomial function, then we get we divide it with generative polynomial function. If we get a reminder, that is just reminder which receiver will read. Here in CRC, it can detect any length of burst error, up to the degree of generator polynomial function. In CRC, the receiver will detect only that bit of error which is equal to the degree of generative polynomial function. Means that if the generator polynomial function have degree 3 and error, and if there is a more than 3 bit error in transmitting polynomial function, then it may be or may not be detected by CRC. For odd number of error, if there is odd number of error, then EX must have to be odd. As we know that if there is just one term in EFX error polynomial function, if there is a one term, then it should be a 1 bit error. If there is a 3 terms in EFX, means there is odd, then there is a 3 bit error, which is basically which is odd. So if EFX contain odd number of terms, then there is a odd number of bit error in polynomial function. If x plus 1 is a factor of g of x, then CRC can detect all odd number of errors. Here g of x is a factor of g of x. If g of x plus 1 is a factor of g of x, means that x plus 1 means there is 2 terms, means it will be 2. If g of x is divided by 2, means it should be even. If any number is divisible by 2, then its number be a even number. So we see that g of x has even number of terms.